enter, and here you go. So what I want to show you from this picture is very interesting thing. This is my physical server, right? But if I go inside and check, then I will find so many things there. Okay, suppose this physical server has 128 CPU, 512 GB of RAM, and 12 terabyte hard disk. It's a big server, right? What I could have done on this server is I could have installed Windows operating system on this server, and then I can run a web server on top of it. And this is my old server, right? And that is what used to happen in past. One server mean one application. Maybe it's a web server or a file transfer protocol server or anything, right? But believe me, if I install only Windows and only one server on this physical server of this much capabilities, it is going to be wastage of resources if I don't see much traffic, right? What can I do? I can install a different kind of hypervisor or a different kind of operating system on this physical server. And believe me, now this hypervisor or this operating system has different capabilities. What is the meaning? The meaning is now on a single machine, now on a single server, you can run various virtual machines or various machines. Maybe this guy is running a Windows operating system and you are running web server over it. This guy is Linux operating system and you are running something else over it, something else, right? It is not the case that you can run only two different virtual machines. You can run maybe many, right? Depending on your server configuration. Virtual machine 1 is using 8 CPU, virtual machine 2 is using 32 CPU, you have 128 CPU. Believe me, you can run many more virtual machines like this. Interesting, right? So basically, this hypervisor control your real hardware. What is the meaning of real hardware? The meaning is that you have 128 CPUs, 512 GB RAM, right? And if you run virtual machine inside it, then it's the responsibility of hypervisor to distribute these physical hardware amongst these virtual machines, right? And one such hardware which is closest to network engineers is actually network interface card. Suppose this machine is having only one network interface card, right? Interesting. And you have different virtual machines. If you see a particular virtual machine, open its network property, you are going to see that this machine is having one NIC, this machine is having another NIC. It means that you can configure one IP address here like 192.168.10.20 and here 192.168.10.10, right? And if these machines wants to communicate something outside my laptop, right? Maybe this laptop address is 192.168.10.30. Everything is part of the same network. Then they can communicate. How? Because believe me, these NICs, right? These NICs are just the software NIC. And that is why you can see two here, right? Or if you have 20 virtual machines here, you can see 20 network interface card. These are software, copy paste, and as many as NIC you can create. But the physical NIC is only one. Only one. It means that these virtual machines, when they want to communicate outside, they can communicate outside, but through only one NIC. It means that hypervisor, sorry for this, hypervisor is actually distributing only one NIC to these many virtual machines, right? This is the responsibility of hypervisor. And by the way, it is not doing anything different because suppose on your computer, if you are running two programs, right? Believe me, your CPU is giving almost equal time to every program. It means that your CPU is shared. Your CPU is shared with respect to maybe your WhatsApp application, or um, if you have opened the Chrome application or anything, right? Your CPU can run only one command at a time, but it is so fast that it gives you a feeling that you are working on all the applications together, but not. CPU is not doing that. And this is the responsibility of operating system to move the CPU between these applications so fast so that it gives you the feeling that it is running that it is running concurrently. So it is not the new thing which hypervisor is doing. It is just distributing this single NIC to various NICs, various virtual NICs. As simple as that, right? But now here is the problem. Before discussing the problem, let's see the traffic flow, how it is going to be there when my virtual machine, which is having 10.10 IP address, wants to communicate with the laptop, which is outside, right? Let me draw the traffic path. Here you go. The traffic will come out from here. It will go to the NIC card. NIC card is going to send it to outside. It will reaching the switch here, and then it can go back. As simple as that, right? But here is my problem, and this is a huge problem. So when somebody was developing this hypervisor software, he was thinking that that is fine, that these virtual machine can communicate outside, but what is going to happen when these virtual machine wants to communicate with each other? And to begin with, this problem is looking simple, but try to understand this problem is really difficult. These two virtual machines cannot talk, and you must be thinking, Mr. Vishnu, you are wrong. I have seen these virtual machines are talking, right? If they are in the same server, they can easily talk. But believe me, with this setup, they cannot talk. How? Let me show you. We have read about switching, and we have been reading, we have been understanding this switching from last 11, 12 classes. And the basic rule was that if this switch receives a frame on a particular interface, if switch MAC address table has the entry for the destination MAC, then it is going to forward on the respective interface, right? But if the interface is not there, sorry, if the MAC address is not there in the CAM table, then the switch, for this switch, it is unknown broadcast, right? And it is going to forward on all the interfaces. Interesting. But it is not going to send back this frame to the same interface on which it was received. You all know about it. It will never go on to this interface, believe me, right? Now, consider what is going to happen if this 10.10 machine wants to communicate to 20.10 or 20.20. I am just writing the last two octets. The starting two octets are 192, 168. Just presume. What is going to happen, guys, is 10.10 wants to communicate to 20.20, right? Or sorry, extremely sorry. Suppose for the first thing, these are in the same subnet, maybe 10.10 and 10.20. So basically, they do not need routing. If that is the case, what is going to happen? This guy is going to send an ARP message, right? What is going to happen? This ARP message will be here. It will be going out. It will reaching on this interface of the switch. Of course, if something else is connected, because this is ARP message, it will be going here, it will be going here, but it is never coming back. And if it is never coming back, then it is not going to reach to 10.20. And if it is not going to reach to 10.20, VM1 will never going to be, right? Know what is the MAC address of VM2. Maybe it is B colon B colon B. Interesting, right? And if that is the case, these two guys cannot communicate. You must be thinking that, Mr. Vishnu, what if I resolve the MAC address, if I put it directly entry, even in that case also, it is not going to communicate. Why? And the reason is the message will come here, again here. Switch cam table is not going to have it, right? The destination MAC. It is going to understand it's an unknown unicast. It is going to broadcast it on all other ports. but not on the same port. And if that is the case, again, the message will never be received back. And these two virtual machines cannot be communicated. And that is the problem which these hypervisor guys were handling, right? They were thinking that it is absolutely no problem that if we want to go outside and communicate, right, to host connected, but if I want my VMs to be communicated with each other, they are not going to be unless I do something else. It's a very, very interesting thing, right? So some wise man came and he suggested that at the end of the day, this switch is doing all the things, right? This switch is not sending the message back. What if I implement a software switch right here inside this hardware? Or you can say, just like whatever I have my software NICs, these are just the software code. Why can't I write the switch as a software code just inside this? This is going to be my virtual switch, right? Interesting. If that is the case, then basically now these two virtual machines can communicate, and then the structure should be looking like this. So these hypervisor guys, believe me, they have created or invented this virtual switch, and they have written the code for it just like a switch. This has the same capabilities like the switch, mostly, right? It is having the CAM table where it stores the addresses, whatever it is going to learn. Now, what is going to happen? This machine was 10.10, this machine was 10.20. What is going to happen if they want to communicate with each other? If they want to communicate with each other, then they are going to send ARP or whatever, right? And now we have a switch here. It is going to be here, the here, right? Everywhere, if it is an ARP, it will be resolved. This machine is going to reply back, and then the communication can happen without any doubt, right? Really, really interesting. Now, these hypervisor guys went one step ahead. What did they do? What can happen? These switches or these virtual machines, sorry, can be part of different VLANs also, right? Or different networks also. Maybe this machine is having address 10.10. There are other machines having address 10.20, 10.30. Three machines are in maybe VLAN 10. And then other three machines, you can say, are having 20.10 address, 20.20 address, 20.30 address, maybe, right? If that is the case, we have same structure like marketing, sales, right? And engineering. Maybe these machines, these virtual machines belong to different groups. If that is the case, just like we have VLANs concept here, we need to implement concept here also. We need to say that this port of the switch can belong to VLAN 10. This port of the switch can belong to VLAN 20. Interesting. And this is what? This is the virtual switch. This is not the real switch, guys. But it is working like a switch. So these guys, hypervisor guys, want to work something differently. So they say, in real life, we call them as a VLANs, but here we will call them as a port group because we are grouping the ports. And actually, in VLANs also, we are grouping the ports itself on the switch. As simple as that. But these guys is calling as a concept as a port group. If they say port group 10, it means that it belongs to VLAN 10, right? But here is my problem. If that is the case, suppose we have a machine 10.10 which belongs to VLAN 10. We have a machine 20.20 which belongs to VLAN 20. This is port group 20 or the VLAN 20. This is 10. If that is the case, what is going to happen? Suppose we have two different machines here. This is my machine number A, which is in VLAN 10, and the IP address is 10.20, right? And suppose this address is 20.10 for the better clarity. And we have another machine B, which is part of VLAN 20, right? And then the IP address is 20.20. Interesting. Now what is going to happen? How these machines are going to communicate with each other? If I send a message or a frame from 10.10, it will come to VLAN 10. It will be reaching to this NIC, and now I am sending it like this. And here is my problem. How come this switch will know that this traffic is for VLAN 10? If the switch doesn't know, then it's a problem, because it might be the case that the other machine can send a frame. I'm showing it as a from a red pen, right? Again, it will be going like this. Again, it will be reaching to switch, right? On a simple interface, we are receiving two messages, right? From different VLAN. What do we do in case of switches? In case of switches, if that is the case, we have a trunk interface. Trunk has a special property that it can carry data from different VLANs. How? It is going to tag the frame. It will say this is for VLAN 10, it is say this is for VLAN 20, and we call it as .1q tagging, right? But here we do not have any tagging. If that is the case, then how VM or virtual machine 1 from VLAN 1 or 10 can communicate to host A, which is right here outside, right? It's a problem, right? So basically, in case of two switches, it was not a problem because we have a trunk link. Now we have a server and a switch. What would happen if I say that this server understand trunking? If that is the case, then one thing happens. These hypervisor guys were really intelligent. They are saying now we need to make sure that the system understand trunking. If that is the case, I can make this link as a trunk, and before sending the traffic for VLAN 10, I will be marking this frame as VLAN 10, and for VLAN 20, I will be marking them as a 20, right? It means that what we are doing at server level, see, first we inserted virtual switch in it, right? Now there is another need. What we are doing now, we are explaining it that Mr. Server, you now need to understand trunk, because now you have virtual machines from different VLANs. And if that is the case, you need to tag it when you send it out. Really interesting, right? Now, see what we are doing. We are just looking inside a server. We are just improving it, and we are seeing what happened in server over a period of time. Previously, only one operating system, few NICs, and you are all done. Now, many virtual machines, right? But here, one problem which I could see, the problem is that there is a single point of failure. Suppose we are running 20 virtual machines inside it, and what we have? We have just one NIC, one physical NIC. If this goes down, then 20 virtual machines are not going to reach outside. Or maybe Sports India main server, suppose running on this virtual machine. Maybe it's a huge server. If that is the case, if this NIC goes down, then we have a problem. We are not able to reach to this server. Interesting, right? Single point of failure is not liked by any network engineer, and they always look for redundancy. Can we do something, right? So that single point of failure can be avoided. And you all know, in case of switch, what we do, if we have a single link, then basically if this goes down, then basically the connectivity, however, how many hosts you have here, they are not going to reach out, right? What do? We connect one more link. If we do that, a spanning tree is going to block it. But what we do for that, we put that in ether channel so that a spanning tree make it up and it up also, right? Now we are revising everything, whatever we have learned, right? spanning tree, ether channel, trunk port, VLANs. Why? Because actually everything is implemented right there in the server, right? We need to understand server networking because we are network engineer. We want to see network, we want to see server from the network perspective, right? At least this much should be known to every network engineer. Believe me, it is just a start of virtualization. Virtualization is absolutely huge, right? But easy. Now, let's talk about what is going to happen if we introduce two NICs. Interesting, right? Now, that wise man again said that we can do one interesting thing. We can have two NICs, right? And if this hypervisor can make this system understand trunk, VLAN, a virtual switch, why can't this hypervisor understand LACP also? If you are wondering what LACP is, then it is a bad thing, right? Why? Because we have learned about LACP, that is a protocol which is necessary to build ether channel, right? If you want to do that, right? If you want to negotiate ether channel dynamically, it's a link aggregation control protocol. It is standard protocol. It means that if you are running a Cisco switch with Juniper switch, you can do LACP. You can make ether channel, right? And now hypervisor guys are saying that LACP is right there. We understand that. I will tell these two NIC to send LACP packets. And if that is the case, then switch doesn't have any problem, right? Because it doesn't care what is at another end. If it is capable of doing LACP, if I am capable of doing LACP, I can make ether channel for sure. And this is what switch understand LACP. Now these hypervisor guys are making these ports understand LACP. These are sending LACP. It means that you can bundle this link using a technology called ether channel, right? If that is the case, the problem is solved. Absolutely, problem of one NIC is solved. Now we do not have single point of failure. If this link goes down, we have another link in the channel which can work as it is, right? Interesting. But do you think that we have solved all the problems? No, because you are network engineer, you always look for redundancy, and now you are saying, Mr. Vishnu, here we have a problem. Although you have solved the problem of link, if one link goes down, then we have another link. But at the end of the day, both the links are connected to a single switch. What is going to happen if this switch goes down? Now, there is not one machine which is connected, Mr. Vishnu, here. There are more than 20 machines or maybe more than 30 machines which are running inside this physical server. And if that is the case, all those 50 machines or 30 machines cannot go out, although they can communicate internally, but they cannot go out. If they cannot go out, it's a problem, right? Because we have single point of failure again. Then that wise men come. Now it is not a server problem though, and now server guys are saying, hypervisor guys are saying, no, it's not my problem. You said you should understand VLAN. I am understanding VLAN. You said you should have switch. I am having a switch. You said you understand LACP. Now I understand LACP. But how you are going to handle the problem, Mr. Switch, right? And switch basic problem was that if we have one switch, if we have switch number two, this is switch number one. If we connect several links between them, if we do not do anything, spanning tree going to block these two links, right? You all understand. But if we do ether channel, then there is no problem. But again, this is the single point of failure. It is the it is not the problem which exists because of this hypervisor. There was a problem, right? So these guys were thinking now, real network engineer was thinking, what is going to happen if we have another switch and we connect something here also and we make one port channel? Really, really interesting, right? So the hypervisor wise man again came into picture and said, it would be great that if I make LACP here, because now I understand LACP, right? So for me, it is going to be just sending LACP message. It would be great for the network engineer who are building these switches, these routers, right? Provide me something so that I can make LACP with two different switches. And along with that, they are saying that I do not want to do any change from my side. I have done enough routing or switching, right? I have implemented enough switching and routing in the hypervisor itself. Now it is your problem. You give me the solution because now I have the link redundancy, but not the switch redundancy. Give me the switch redundancy, right? And we already have seen this problem. But in the case of campus networking, we do not care about it. And the reason is that from this switch interface, only one laptop or PC is connecting. If this something gets failed, then few of the users are impacted, right? But here we are not talking about one user or 10 users. We are talking about suppose 10 or 20 servers are running means we are running. If one server is running 10 virtual machine, we are talking about 200 machines, right? Which are connected over a single switch. If that is the case, it's a problem, right? Exactly, we are needing these things in the data centers, right? Campus, that is fine. I'm not saying that campus it is not required, but we have somewhat similar solution for that. But here it is the need of an hour, right?